In today's lecture, we study the CE amplifier. Now we see how to draw the CE amplifier. In the last lecture, I have explained the different types of biasing. In that, voltage divider bias we use for the more stability. So now here I will show how to draw the CE amplifier, and each and every component is what purpose. Now let me explain. Now this is the NPN transistor, base, emitter, collector. Now for the base, I am applying the voltage divider by using the R1 and R2 resistor. This is R1 and this is R2. So by using these two resistors, applying the biasing, so this is called the voltage divider biasing. Now at the collector, connecting one more resistor, that is called RC, to control the load current, and RE resistor is connected to the emitter for the negative feedback purpose. So what is the meaning of negative feedback purpose? It stabilizes the output voltage and also it will reduce the noise. So at the input, along with the information, if any noise is present, that will be minimized by using this resistor. So this is for the negative feedback purpose. And so if I connect the supply like directly to this amplifier, then the DC current, now in the voltage divider biasing, I have already explained that. Now here the VB voltage, now without applying the supply, now with this DC, this VB is equal to what? VB is equal to VCC divided by R1 plus R2 into R2. Now here we are providing the VB voltage to make this junction on. Now when I connect this supply directly to this junction, then the current, DC current flows in this direction, and here internally here in this supply, internal resistor is there, so it will drop some voltage. And also this resistor, it comes in parallel with this R2, and no more we maintain this VB. So thereby what, the biasing, no more we can't keep this junction on. So for that, this DC current should not flow in this direction. So for that, here we are connecting one coupling capacitor. Now see in input coupling capacitor, so which will allow the AC current in this direction, and it will block the DC in the opposite direction. And one more capacitor we need at the output side. Now why are we using this biasing? So to keep this junction on, so that this signal should appear at the output with the amplification. So after that, after the amplification is done, at the output we need only pure AC signal. We don't want any DC. So that DC should be blocked by the output coupling capacitor C out. So now here I am taking the output voltage. This is the C out coupling capacitor, which will block the DC and allows AC. And this coupling capacitor is also useful. We use for the coupling the next stage or next CE amplifier, next stage. So and one more capacitor we are connecting across the RE to bypass the AC component. Now this RE is for what purpose? Of stabilizing the output, I said. Now if output is increasing, now if this is my now if output is going beyond the limit, now if this is my output, if it is increased like that, like this, then what happens? Output current also increases, thereby here the drop increases. So if the drop increases means what is VB? VB is equal to this, I said. Now it is a fixed one. So now VB is equal to, I can also write it as, now in this loop if I put the KVL, so VB is equal to VBE plus VE. Now if this drop increases, thereby now VB is a constant value, now VBE will reduce, thereby what? Conduction of the transistor reduces, thereby the output current also reduces. So and again we get the output normal like this. So if output current is reduced below our range, then here the drop will reduce, thereby VB will increase. So VB increases means what? Conduction of the transistor increases, and the more current flows at the input and also more current flows at the output, it will maintain the output voltage constant. Like that, how much the current is flowing through the RE, it will try to maintain the output voltage constant. If more current is flowing, then it will reduce the conduction. If the less current is flowing, it will increase the conduction. Now here, after connecting the AC, if both AC and DC signals, AC and DC current, both currents are flowing, So if along with the DC, if AC current is also flowing, then here the drop will increase, thereby the overall gain will reduce. So that is not that should not happen. Means what? Only DC current should flow through the RE and AC current should flow through the CE. This is nothing but a bypass capacitor, CE bypass capacitor. So this is used to bypass the AC component or to ground the AC component. So if AC component is not flowing in this, so then the DC biasing will not change and we get the faithful amplification at the output. So this is about the construction of a CE amplifier. Now how the amplifier works, now that we will see. Now if the input side, if I applied some voltage, that is a 20 volts, or otherwise if I take this as a IB current, so this is a 20 micro amp. This is a 20 microamp. Positive peak is 10 and the negative peak is minus 10. Now without this AC signal, with this DC plus VCC, with this DC, if current is flowing, IB current is flowing, that current, if I assume that IB current is equal to 30 micro, then with this after applying, now here it is a capital IB, that is with the plus VCC, and with this AC also some current flows, that is small IB, that is a AC current, that is plus 10 micro and minus 10 micro. If this plus 10 micro is added with this 30 micro, then it will go to the 40 micro, and if minus 10 is added with this plus 10 plus 30 micro, it will go to the 20 micro. Thereby what? Here at the output we get the graph like this, and this is equal to 40 micro amp and this is 20 micro amp. Now within this input current flows. Now if this transistor beta value is 100, then for this I will get, now for this I will get here how much? 3 milliamp, and here it is a 4 milliamp, here it is a 2 milliamp. Why I will get like this? So IC is equal to beta times of IB. How much IB you are applying, that is multiplied with the beta. Now here in this example I have taken the beta is equal to 100. That's why we get this currents. Now how the input current is changing? Similarly output current is also changes. If input current increases, output current increases. If input current decreases, output current is also decreases, but with the beta times. Now if I take the DC load line, now this is the DC load line, this is VCC value, this is the IC sat or IC maximum value. Now where it is intersecting this point, this is called the Q point. So this is the Q point. Now this and this, now these are the limits. Now within this range our voltage will vary. Now if the input current is increasing, output current is also increases, but at the time output voltage reduces. Why it reduces? Now take the KVL at the output side. Now what is the expression for the output KVL? So VCC, now applied voltage is VCC. Now for VCC is equal to, what are the drops? Now you see here, this is the current, which here what is the current? IC current. IC into RC, this is the drop VCE junction voltage, and this is the IE into RE. Now where IC is almost is equal to IE, then we can rewrite this expression as IC into RE plus RC plus VCE. Now in this is a constant, VCC is a fixed value. If IC is increasing, thereby what? VCE reduces. If the IC reduces, then VCE increases. That's why if we substitute this IC values in this expression, then we get the voltage like this. So with this what we understood, now if I apply the input voltage like this, then at the output I will get amplified signal, I will get, but with a 180 degrees phase shift. This is the V in or Vs, this is V out. So this is the amplifier. Now if you apply a small voltage over here, with respect to that current will increase. If IB current increases, IC current also increases. If IC current increases, then VCE reduces. If input current reduces, then the output current also reduces, with that VCE increases. Now this is about the CE amplifier. Now in this we need to know the frequency response. Now what is frequency response? Keep the input voltage constant. Now here input voltage, keep it constant and vary the frequency and observe the output voltage. Now here on x-axis I am taking the frequency in hertz and y-axis I am taking the gain. So output voltage, this is in dBs, gain in dBs. Now our gain is equal to AV is equal to, what can we take? AV is equal to output voltage divided by input voltage, where output voltage is directly proportional to the gain. So now if vary the frequency and take the output voltage and convert that voltage into the gain in dB, and if you plot the graph will look like this. So what is the meaning of this? If the frequency is increasing, gain increases, and it maintains a constant for a few frequencies, and after that again for higher frequencies again gain reduces. Now this is the maximum gain, A maximum. Now for this, if you subtract the 3 value, 3 dB, we call it as a 3 dB. If you subtract the 3 value and put a dot line, and where it is intersecting, so this point you can call it as a VL, FL, this point we can call it as a FH. Now bandwidth is equal to, bandwidth is the difference of higher frequency to low frequency, FH minus FL. Now these are, the bandwidth is nothing but a set of frequencies where we can operate the amplifier. This is a frequency response curve. Thank you.